Those oxides which are neither acidic nor basic are called neutral oxides. For example, CO, NO, N2O and H2O. Ozone. Ozone is allotropic form of oxygen. Under certain conditions, 3 atoms of oxygen combine together to form triatomic molecule of ozone. When a dry, slow stream of oxygen is passed through a silent electric discharge, there is partial conversion of oxygen into ozone. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use silent electric discharge. The apparatus used to obtain ozone is called ozonizer. Siemens ozonizer. It consists of 2 coaxial glass tubes sealed at one end. The inner surface of the inner tube and outer surface of the outer tube are coated with tin foil. It gives 10 to 15% ozone-oxygen mixture. Properties of ozone. Pure ozone is a pale blue gas with a characteristic pungent smell. It is slightly soluble in water. Ozone is thermodynamically unstable with respect to oxygen, since its decomposition into oxygen results in liberation of heat and an increase in entropy. Due to ease with which ozone can liberate an atom of oxygen, it acts as a powerful oxidizing agent. Under the action of ozone, a shining silver surface blackens rapidly, being covered by a layer of silver peroxide, Ag2O2. When ozone is passed through mercury, it loses its meniscus and sticks to the glass due to formation of Hg2O, which dissolves in mercury. This phenomenon is called tailing of mercury. Uses of ozone. The important uses of ozone are following. It is used as deodorant to destroy odor in kitchen and restaurants. It is used for bleaching oils, flour, starch and ivory. It is used as germicide and disinfectant for sterilizing water. It is used in the manufacture of artificial silk and camphor. Allotropic forms of sulfur. Rhombic sulfur. This is the most stable form of sulfur. It is obtained by slowly evaporating a solution of roll sulfur in CS2 when octahedral crystals of rhombic sulfur are formed. This is lemon yellow in color. Monoclinic sulfur. If crystals of rhombic sulfur are slowly heated to 369 Kelvin, they slowly change into needle-like variety called monoclinic sulfur. This form is stable above 369 Kelvin. It has dull yellow color. It is insoluble in water. At 369 Kelvin, both rhombic sulfur and monoclinic sulfur coexist, and this temperature is called transition temperature. Sulfur dioxide. Sulfur dioxide can be prepared by burning sulfur. In laboratory, it is prepared by the reduction of H2SO4. Metals react with hot and concentrated H2SO4 to form SO2. On commercial scale, sulfur dioxide is obtained by roasting sulfides. Roasting means heating a metallic sulfide in presence of air or oxygen and converting sulfide into an oxide. Properties of sulfur dioxide. It is a colorless gas at ordinary temperature and has disagreeable and suffocating smell. It reacts with alkalis, forming sulfides and bisulfides. In the presence of moisture, it acts as a bleaching agent. It is quite soluble in water and solution is acidic. It acts as a strong reducing agent in aqueous solution. It acts as a good oxidizing agent. For example, at 1000 degrees Celsius, it oxidizes carbon into CO2. Uses of sulfur dioxide. The important uses of sulfur dioxide are following. In the manufacture of H2SO4, H2S and calcium hydrogen sulfide, which is used in paper and pulp industry. It is used as an anti-claw and disinfectant. It is used as a preservative for canned food. It is used in refining petroleum and sugar. It is used as refrigerant. It is used in bleaching. Oxoacids of sulfur. The sulfur oxoacids are chemical compounds that contain sulfur, oxygen and hydrogen. Sulfur forms a number of oxoacids. Some important oxoacids of sulfur are the following: H2SO3, sulfurous acid; H2S2O4, diathenious acid; H2SO4, sulfuric acid; H2S2O3, thiosulfuric acid; H2SO5, permonosulfuric acid; H2S2O8, per-disulfuric acid. Some of these acids are unstable and are known in aqueous solution or in the form of their salts. Sulfuric acid. It is the most important oxyacid of sulfur. It occurs in certain minerals and springs. It has large application in industries and is also known as the king of chemicals. Sulfuric acid is manufactured by contact process. The process involves the following steps. Production of sulfur dioxide. It is carried out by burning powdered sulfur or roasting of sulfur-rich ores. Oxidation of sulfur dioxide. This step is the key step in the manufacture of sulfuric acid. To yield better sulfur trioxide, the favorable conditions are the following. Temperature. As the reaction is exothermic, a low temperature favors the forward reaction. An optimum temperature is maintained between 673 to 723 Kelvin. Pressure. A high pressure favors the process. An optimum pressure of 1.5 to 2 atm is maintained. Catalyst. At such a low temperature, the reaction is slow. The catalyst employed is divanadium pentoxide V2O5. Excess of oxygen. To have a better yield of SO3, O2 is used in excess. Conversion of SO3 into H2SO4. SO3 is absorbed in concentrated H2SO4 to get oleum. Oleum then is diluted with water to get H2SO4 of required concentration. Manufacturing of sulfuric acid. The manufacturing of sulfuric acid starts from sulfur burner. Here, sulfur dioxide is produced. This sulfur dioxide passes through dust precipitator, which removes dust from the gases. A scrubber is used to remove the soluble impurities. After that, drying tower removes the moisture from the gases. Then, gases pass through an arsenic purifier which removes impurities of As2O3. The gases coming out of the purification unit are passed through the testing box to make sure that they are completely free from the impurities. The pure gases coming from the testing box are preheated to 673 to 723 Kelvin in a preheater. The hot gases are then passed through the catalyst chamber where SO2 is oxidized to SO3. SO3 is introduced at the base of the absorption tower, from the top of which concentrated H2SO4 is showered. As SO3 gas moves up, it is dissolved in sulfuric acid, forming oleum, which may be drawn out from the base of the tower. Oleum is then diluted with water to get H2SO4 of the desired concentration. Properties of sulfuric acid. In pure form, it is colorless, but commercial acid is yellow in color due to the presence of impurities. On coming in contact with the skin, it produces severe burns. Concentrated H2SO4 has a great affinity for water. Its dissolution in water is highly exothermic in nature. Highly concentrated H2SO4 has high boiling point of 621 Kelvin. It shows that H2SO4 has associated structure due to hydrogen bonding. On heating strongly, it dissociates into SO3 and H2O. Uses of sulfuric acid. The important uses of sulfuric acid are following. It is used in metallurgy for electrolytic refining of metals. It is used as a dehydrating agent. It is used in storage batteries and lead accumulators. It is used in fertilizers for the preparation of ammonium phosphate, ammonium sulfate, and superphosphate of lime. It is used for cleaning of metal surfaces before electroplating. It is used as an acid in laboratories and industries. Did you know? Sulfur is used as fungicide to protect grapes and strawberries. Oxygen was discovered by Carl Wilhelm Scheele in Sweden in 1771. It was named by Antony Laurent Lavoisier in 1774. Selenium is widely used in rectifiers and in xerography. Summary. Let us summarize what we have learnt. The elements of oxygen, sulfur, selenium, tellurium, and polonium constitute group 16 of the periodic table. Elements of 16th group have relatively high electron gain enthalpy values which decrease down the group. Oxygen molecule is diatomic and under normal conditions exists as a gas, while other elements have larger atomicities and exist as solids. Oxygen shows oxidation state of -2 in its compound, while other elements show additional oxidation state of +2, +4 and +6. A binary compound of oxygen with another element is called oxide. Oxygen combines with most of the elements to form oxides.